robotics, and autonomous devices all around us. Today, our cleaning our houses with robots. We are sending satellites running autonomously around our world. We are doing agriculture using mobile robots, doing autonomous jobs, and so on. And this autonomous world growing and growing today. Welcome, and I'm going to introduce you now, today autonomous devices and self-driving cars. Who am I? I'm Serhan Gökçebağ. I am an entrepreneur, space enthusiast, software and system architect. Almost 2 decades, I am doing this profession in space and aviation and robotics area. Currently, I'm owner of startup Samaratuk and providing systems and software consulting services, doing remote expert evaluation for European Commission, and I'm today here to talk about self-driving car. With our company, we are working on various projects on autonomous robots. We are developing some ideas on autonomous algorithms and developing mobile robots as a part of R&D work. With this R&D, we are paving the way to autonomous self-driving vehicles. Today, I'm going to talk about in detail what self-driving is. But before doing this, I wanted to mention about our projects with cloud-based system management for autonomous robots in corporates, and also we are doing precision agriculture systems for monitoring our vineyards, for example, or other agriculture areas in our gardens, observing food development and so on. Autonomous vehicles are today coming much more usable, and we are finding everywhere. With self-driving, we are now developing future technologies. We are expecting in near future to our cars go by themselves, and we are going to sleep and maybe read books during autonomous car going around. When we are talking about self-driving vehicle, let's see what kind of architecture we have. We have a car equipped with some sensors which helping autonomous car to self-drive. What we have: main computer, LiDAR unit, cameras, radar sensors, and additional sensors for all purposes. How does an autonomous vehicle work? Generally, it works with their understanding their environment. We call autonomous vehicles world model. In a world model, we call it as a space of working area. Autonomous vehicle consider itself in a autonomous world and use its sensors, GPS, inertial navigation system, LiDAR, radar, cameras, infrared sensor, ultrasonic sensors, and odometric sensors to move on. Autonomous process in its work model has main 4 steps to operate in a work model. First of all, vehicle collects all sensory information around, and we call it sensing. When autonomous vehicle senses its environment, then it needs to understand where it is located and determines its location, and we call it positioning. After sensing and positioning are completed, with using its built-in artificial intelligence algorithms, autonomous vehicle determines its movement in the next 3 or 5 seconds. It calculates all other surrounding objects' position, their movement, and vehicles itself calculations. Then, after completing estimation, control comes in effect, and autonomous vehicle moves according to its mission plan. And this process goes indefinitely until the mission completes. As we described in estimation process, all this calculation and information fusion is calculated by using artificial intelligence algorithms. And when we talk about autonomous vehicle, we are actually talking about artificial intelligence. In various AI algorithms and models are developed in a standard autonomous vehicle. Let me give an example for clearance. When we use LiDAR sensor, we send laser signals all around, collect it, and fuse it to form a mission picture of radar sensors and LiDAR sensors all together. And all these things are calculated using AI algorithms. When we talk about automated vehicles, autonomous vehicles, we are talking about levels of autonomy. Levels of autonomy can be described in 5 levels. When we drive a car in our conventional way, we call it level 1, and we are only driver's experience. We are driving only with driver's experience. When we start talking about assisted driving that nowadays started to develop, we have some helper sensors. We call them ADAS systems, automated driving, adaptive driving assistance services. These services provide some information for driver to get rid of some danger during driving. And whenever you are using in a rural area, for example, in night, if you use cameras or LiDARs, you can get warned by some animal, for example, coming towards the road and warns you before you hit it. And when we go forward, partially automated, we deliver some capabilities to car's capability. Like when we increase our speed and we don't get any warning, car starts to decelerate by itself with this automatic control systems. Likewise, if you just run out to other lane, car keeps moving in its lane. And at this point, we go to higher automation level, level 4, highly automated. Driver then leaves the car, car starts to drive itself, self-driving, and whenever it is required, autonomous vehicle keep going. But if something wrong, driver can take the car's control and get rid of the danger if it is required. And when we come to the level 5, fully automated self-driving car, autonomous vehicle, then driver needs to do nothing. Everything will be performed by self-driving cars, artificial intelligence capabilities. With this fully automation to be work properly, we need to have our infrastructure autonomous vehicle ready. What do I mean by saying this? Traffic lights, signs, asphalt conditions, and all the infrastructure need to be connected. We call this as a V2X technologies. What is V2X technologies means? Vehicle to everything. Vehicle communicates with everything on the road. And this requires all this infrastructure to be compliant with each other and use similar protocol to use and utilize this full automation. Here are some examples of automated autonomous vehicle experience. Most of you might ask if it is utopia or it is now something we are using, experiencing. Yes, we are starting to experience it in various places of the world, like autonomous convoys with trucks. It helps to decrease carbon emission, for example, to use autonomous convoy. Convoys are following each other, trucks are following each other in a convoy formation, for example, to reduce the risks of driving and reducing fuel usage, carbon emission, and need for extra drivers for all of the trucks. And this is this picture on the right is shown from this EuroCap challenge. Truck manufacturing companies attend to this challenge and demonstrate their capabilities, like Scania, Volvo, Mercedes, and various models. And we see them on the roads today. For the left upper side of this picture in the slide, we see Daimler Mercedes, one of the features. This is fully automated and autonomous vehicle for delivering goods to dealers, delivering meats, delivering cargoes, whatever, all autonomously. It doesn't contain any driver in it, it just receives mission plan from mission plan center, and then deliver all the goods from retail houses. Nowadays, there are autonomous buses right bottom corner of the slide. These are started to be used as a shuttle services, and some countries, we are going to demonstrate some videos next and show you example of these usage areas. Some advanced topics to be mentioned here. As I said previously, vehicle to X technologies are very important for autonomous vehicles to operate in real-time environments. And when we get there, we are not going to see any drivers for autonomous vehicles. But we have some problems, cybersecurity problems. And these are the challenges to be solved in near future, because when we communicate to V2X infrastructures, some bad guys might get interfere and get control our vehicles, and you can think about what kind of problems they might cause with using this control. And here I finish my presentation with topics. I would like to show you my videos about the topics here.
And we also have some questions, but we can keep them for after the videos.
First video is about vehicles how vehicle sees around in real time, real life, with using LiDAR sensor. As you see, it scans continuously around with LiDAR and calculates distance, very precise distance with the other moving or still objects around it. And this information is used by main computer of this car to be calculated. This is how autonomous vehicle understand its environment by sensing, which I previously mentioned in our presentation. Our second video is about autonomous truck convoys. These videos are from this Eurocup challenge. Drivers are using driving connect capability, which I mentioned, vehicle to X communication. They discover if there's a connectable autonomous vehicle around. And now you will see how automated drive assistance systems will take effect in this driving with the radars and lidars. Obstacles are detected and autonomous convoy are follow each other to stop whenever the danger came in effect on the road. You will see when the drivers are driving, sometimes cars can get in between two trucks, and trucks will open their distance according to their algorithms. When some truck need to leave convoy, they decrease the gap according to safe driving distance. You see in here, keeping its distance automatically. This level of autonomy is level 4, as you remember. Drivers are ready to take control whenever there's some interference or there's a problem on the road like this. Just disconnect from autopilot and then take the control. You see, manual line change required. If it would be full automation, you will not be seeing any driver in the middle trucks. Only the leader truck will have driver, and the leading followers will have no driver. These technologies are now being developed, still being developed, under development, and logistic companies, military companies, all companies are developing their technologies and concepts according to this autonomous driving, based on autonomous driving technologies. Yes. And our last video is from public transport. In Greece, high-tech company provided some driverless buses in city center, fully autonomous. This is not Ethiopia, and these are on the roads now. These are operating. You see the LiDAR image in bus. These are GPS receivers, LiDARs, and antennas, cameras. And these buses are go around in the city to deliver transportation service. These are all that I would like to talk with you guys. Thank you for listening. And if you have some questions, we can discuss. And
Question. If we got, let's say, student classes to start autonomous, the problem might be inside the bus as well as outside. For example, if 2 or 3 children or even go and start fighting, the bus driver will stop the bus, maybe even call the police or something. In completely autonomous bus, you still need someone there not to drive, but just to keep control of the situation.
yes, it's a good question. here nowadays we are working on systems for children shuttle services, for managing this team actually with the real driver and hostess in the bus, for example. And there are regulations for this to some conditions be met in the buses, like seat belts and occupancy sensors on seats. When the passengers are seated in the bus, children, if they go up and start doing something in the bus, autonomous bus can stop shortly and wait for some assistance to become to finish this unjust thing. For example, there are some AI systems monitoring inside the buses and detects some fight, for example. And as soon as fight is detected in public transport, this information will be sent to control centers that there is a fight in a X numbered bus, and then bus control operation center directly send police or whatever to take control in that.
That's good because when we see students and they need to go to school, parents have to go and then have to go to work. So we have a problem with traffic. Obviously, we can't have the normal buses going to every single house. We need much more buses, many bus drivers. But with autonomous small buses, this might be some kind of solution which is also cost effective. At the same time, someone could say that even though it's going to reduce the number of bus drivers, which is not true because normal buses will continue to work, it will also create jobs because at least one person should accompany students in these buses. So we solve a lot of issues with these autonomous buses. And the good thing is that they don't need any special training. It's just a person who will train just to take care of children. Every day I have to go to these houses, pick up these 10 students and take them to this school.
But then you still need the operations center, like you said.
Yes.
There must be operations center, more jobs.
Yes.
There are
yes.
people sitting in an office with operation systems in front of them, monitoring the routes, monitoring any problems,
yes.
traffic, all those things can be extra jobs.
Yes, because there are many countries. I remember the UK has a huge problem with truck drivers. They don't have. They're hiring from other countries. So it's not just buses here in Cyprus or in Greece or in Turkey. I mean,
the problem is when driver drives this vehicle, every vehicle driver drives in his how can I say,
psychological frame of mind.
Yes, but when we deliver this job to standard algorithm, all the buses will drive according to standard way of rules, and the most important problem will be solved: security and safety on the roads. There are researches on this. 90% of car accidents or similar problems arise by drivers malfunction during their driving. 10% belongs to other uncontrolled things. And when we have these autonomous vehicles on the roads, we will get rid of most of the problems at once.
And especially if we're looking at, let's say, buses for school, because you only drive for specific hours of the day, we could even use small electric buses that charge with solar, so they don't actually need to drive, let's say, more than 2 hours every day, let's say 3 hours. So charging them and zero emission, zero gas consumption. So it's a lot of things coming around for this. And I'm very glad that they chose this topic for First Level this year. Because all the gas prices going up, the shortage of drivers, the security of drivers, this is very good for students to research.
I have a question. You said in your presentation that the sensors then make a decision within 3 to 5 seconds. Do you think that's too long and it should be shorter?
I said within 3 to 5 seconds every.
So at most.
Yeah,
it probably much faster than that.
Much faster, yes.
If a car cuts in front of you, you have
Yes.
to be very, very fast.
Yeah.
I have a question. So, do you think there will be like conversion kits for the cars? Because now, when we check the streets, most of the cars are still old technology. I mean, combustion engines, etc. So, do you think there will be the kits, or will it be possible to take our car somewhere to make it autonomous? Or are they all going to be produced just like brand new? And my other question is it easier to have the EV cars, electric cars, to convert to autonomous cars, or the combustion engines? What are the differences? Or
it's another good question to answer. For the first question, now, according to countries' plans, for example, European Union, for the most developed countries, it is planned to have this level 4 starting from 2025. And after 2035, we will see these fully autonomous cars, level 5, on the roads. And of course, this requires some time to make this transition from normal vehicles to fully autonomous vehicles. That's why I show this 5 level of autonomy. And depending on the conditions, vehicles can be converted to autonomous vehicles, and whether the car is not compatible or vehicle is not compatible, it's discontinued in combustion level. And for the second question, electric cars, electric vehicles, or combustion engine cars doesn't make any difference to make this adaptation. It is all similar to control cars in their original design. And this is how nowadays we are doing this R&D work for regular vehicles. We do install adaptation kits, actually. Design specific boxes to control steering wheel and other systems and get them together, install them ugly radars and lidars on the top of it. But in the future, we're not expecting to see any sensors on the vehicle itself. All the sensors will be disappear in by design, like our mobile phones today. It contains GPS, EMU, accelerator sensors, cameras, and all are very well designed and put in a single small box. Antennas, for example, high frequency. Now we are talking about 5G, and the cars will be designed in industrial design way to best fit as a outside looking.
I think the tipping point for this that you're saying for the autonomous driving is going to be the drive-by-wire. Because right now we have a steering wheel that has a rod and it controls the axles.
Yes.
With drive-by-wire, everything will be digital, so the axles will actually be turning with a digital motor. So instead of having this axle, it will disappear completely, the whole rod will disappear.
Yes.
So the wheel will just be a digital, like a PlayStation or something, and you are just going to send digital commands to the
front and rear.
So when that happens, I think it's going to be much easier for autonomous vehicles because they don't need anything to turn the wheel.
Exactly. And drive-by-wire is a technology now being used in this technology development.
Well, this is all very interesting. I'm quite sure that our colleagues who will participate in first LEGO League this June will take great interest in what you showed us, and I'm quite certain they will manage to get some ideas to enhance or even reshape their project. So we're very, very eager to see what they're going to present this June the 19th, when they have their presentations. I'd like to thank you for this. We should mention that Mr. Serhan we've been working with Mr. Serhan for the past 4 or 5 years, maybe more. And this is a great pleasure. Thank you.